Well, hey folks, welcome back to the shop. Today we have a very special bike all the way from Canada. Can you believe that? So we have Mr. Monty here that brought his bike down. He lives just outside of Nova Scotia. So can you believe that? Coming all the way here just to have this bike in the shop is a really huge privilege. So what we're going to do with this bike is totally rewire all these wires. It's a simple bike with a simple kickstart. Why 20 million wires? We don't know, but we're going to change it. Monty's going to hang out with me in the shop here today. We're going to have a good time, and you and I and him are going to rewire this entire bike, sit down, draw up a brand new plan for it. And this is an 82 Yamaha XS400SJ flavor, and we believe it to be an actual Canadian bike by the VIN on it. And so welcome back to Butler Customs Motorcycle Shop. Okay, so I want to show you, introduce to you Mr. Monty. Monty, come on over here. Hush. Can't have you barking while I'm trying to do a video. Hush. So this is Mr. Monty. Monty, tell us a little bit about your bike, your plans are for it.
Well, I come across a young lad that needed some extra cash to go to school, and I was also looking for a little toy just to kind of play with. I'm a carpenter by trade, but wanted to get a little greasy. So as I played with it, I think I purchased it 4 years ago. And I rode it for a couple seasons, and then I started to pretend I was a mechanic.
So we all do. Yeah.
So I also learned that the further I got into a mess, maybe, the more I would have boxes to bring to somebody. So I kind of stopped and thought, well, I'll leave it as what it is so I don't get into too much of a mess. Plus, being an older bike, I didn't know about parts. So, and again, when I took the tank off and I took all the tape off the wiring with not a lot of signals, I thought, this is crazy. There's too many wires here. So again, instead of making a mess, I just stared at it for the longest time.
Yeah.
And then lucky enough, I come across Kevin's video here. And I was totally pleased, totally excited. I knew that was the fit. So I put everything together I could to bring it down here.
Awesome. Awesome. Well, Monty was kind enough to send me some pictures of it, fully assembled, what it looked like before. And it's a sharp little 400 bike. I think he's going to have a lot of fun on this. And I know he'll do it well and probably pass it on to somebody that'll enjoy it even after him. But you might be asking, what in the world? Why all these wires? And it's got these little no connectors. Don't ever use these. We'll get into here and show you exactly why not to use these. But gobs and gobs of wires. These wires, 5, 6, 7, 8 of them run up here to the headlight, and then they connect to 5, 6, 7, 8 more that run right back through. It's ridiculous, but we'll explain why I think that happened. This looks to be like a kit that you would buy to eliminate the starter. This is a kickstart only. So what we're going to do, and I've studied on it over the weekend while Monty was kind of exploring what we have to offer here in Tennessee. And I'm like, you know what? Let's take today and let's just rewire everything. That way Monty has a good understanding of his bike, what every wire goes to. He's personally handled it. He understands it. And I think that's really good that a rider has a personal connection with our bike where they understand their bike. And not only just hearing it when something's not right, but knowing if something goes out electrically, that, hey, I know exactly what that is. I know where that wire is, and I know how to fix that. I think that's beneficial for all riders to do. So we're not going to do, I wouldn't call this a chopper wiring. I would call this more a minimalist wiring. What is the least minimalist wires we can do that makes this function how he wants it set up. And so we're going to go over here to the table. We're going to sit down with just a manila folder folded out, and Monty's going to draw out with me kind of guiding him exactly what this bike needs as far as wires and what it doesn't. So Monty, you're going to have about a mile long of wires you can take back with you to Canada and tie stuff up with or whatever. So we're going to have a really good time. So let's go sit down and draw out the wiring for this and what it needs. So if you have a Yamaha XS400, you're really going to enjoy this. Or just an older 80s Yamaha in general is kind of the same components. And the good thing is everything looks to be in good shape. We're not dealing with old wires that are brittle and broken. And they use good 14 gauge wires. So with good wires, we're not going to have to be replacing wires. We're just going to be eliminating a lot of wires, shortening things, and making things a little bit nicer and cleaner. Okay, so we have this wiring diagram here, which is, as I studied on it, a kit that you can buy that primarily eliminates your electric start switch, your motor, starter motor, your starter relay and headlight relay, and your flasher cancellation unit. But Monty has decided, look, we're not going to run any turn signals. We're going to do the old school hand wave. And so we're going to be eliminating these front and rear blinkers. And also we have deleted the tachometer and the speedometer. And so we're going to eliminate that. And also we're going to eliminate this kill switch here. Because he has a key switch right up there in the front of the handlebar, I like those better because sometimes you can leave the key on accidentally, kill the bike, and forget the key's on and your battery's dead. So I like just using the key. And these are plastic, so remember, those kill switches on Harleys or anything, they're emergency only. Don't use that to stop your bike at the gas station or daily. They'll break, they'll go bad on you. I always like using the key. It's metal, it's functional, it's made to turn the bike on and off. We're going to leave everything else. As you can see, it's very simple. We have the ignition unit from the motor with the points or the electronical unit. As the cam moves, it sends spark signals out to the ignition unit. The ignition unit then is grounded, of course, to the frame or the motor, and then it comes out and feeds the coils. Now it does have this running to the kill switch, and the kill switch runs off this fuse box with a 10 amp. So we will need this power that goes to the coils to power the coils, and the ignition unit just tells it when to ground and not ground. Now we will need the stator, we will need the rectifier, we will need the regulator, which has all that on the bike. Then you have the headlight and you have the tail light, and that is it. We have a fuse block as well as a 4 connector fuse block. We're going to keep that so we can run the lights off that when the key is on. And so there's a relay, an LED relay in there, but his light in the front is not LED, it's standard bulb. So we might not even need that. We can eliminate that. One of the things I did see that I did not like about this wiring diagram that we need to change is you have the hot post coming off the battery. It's a very small battery because it's kickstart only. It doesn't need that much juice. But it runs all the way over to the rectifier. The rectifier feeds back power to the battery to charge the battery. That's great. But they have placed a 20 amp fuse on this side of the key. The 20 amp fuse should be over here on this side, so that if the rectifier goes wonky and starts overcharging the bike, it pops this fuse instead of popping it on this side. It eliminates that, kills power to that and to the whole bike. So I would move this fuse over here when we rewire it. So what I told Monty, I said, it might be best, Monty, if we sit down and you just draw out a new wiring diagram for your bike. It's in your handwriting, it's yours. You'll go through every piece and know exactly what's going on. As far as this aftermarket switch here, we are going to keep the horn button. We're going to keep the high-low beam button. And he has a passing light button we're going to keep as well. The turn signal switch, we're either going to delete it out of the housing or just leave it on there, but have provisions of wires coming out in case later he wants to add turn signals. or anything. You could use that switch as anything, customize it. Yeah. So at this time, Monty, I want to set this here for you so you can kind of use it to place your things kind of in the layout of this. So I always want to start, I always like to start with a stator because this is going to give us the power out of the motor. So if you just want to draw a circle there and write stator in the middle of it. I've never seen a Canadian write before, so this is new to me. There we go.
Spelt right.
That's right. Now your stator will have 3 wires coming out of it. Those are usually white wires.
White wire.
Very good. And then I always like to write, since we're writing just in one solid color, white, 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 so I know what colors those are. And then you'll draw you a box here for your rectifier. All right, these 3 wires will go into your rectifier, but you'll also need room for 2 more wires coming out. So the 2 wires coming out, one will be a ground. So you can run that off and just put the little ground sign for that. Now, the other wire will come out and come over to your battery. That feeds back into the battery and charges it. So go ahead and draw your battery there. And then you'll put that'll come into the positive here and the negative, and you'll ground the negative out there. Now, on this bike, you have a stator that has to have power back to the stator from when the key is on. That energizes this coil, magnetic coil. So you'll have 2 wires coming out of that stator there. And they call this the brush assemblies, but I wouldn't label it anything. You'll have the brown wire that runs up here over to a regulator. So let's draw a regulator here. It's just that little bitty metal box that you saw on your bike, and that's the regulator. Now what the regulator does is it gets power in from when you turn the key on, it throttles that power down and regulates it to send just a small voltage back to here, because this doesn't need a whole 12 volt to charge. So just a small voltage. So this throttles down. Remember I was talking to you on the multimeter about a diode and what a diode does? So kind of the same concept.
Okay.
All right. And then it'll have this green wire here that comes off. That goes into your regulator. That's as a ground as well. So what you'll have is you'll have a wire that this bottom wire comes off and comes over here into your regulator. Now we won't label that wire yet color wise because we don't know what's on your bike, right? But that's going to feed the power to the stator. You'll have just a ground wire that comes off as well. All right, and then you'll have another wire that's going to run into our fuses and stuff. All right, and anytime your wires join together, just draw you like a little circle there, and then you know that's a junction for that wire. So we're going to put a key switch here, and we're going to run another power off here. We're going to go straight across to that key, and that will definitely be a red wire. No matter what it is on your bike, we're going to change it to a red wire. We need an inline fuse here. So just put you a little block around the wire there. There you go. And we'll probably do a 20 amp fuse. And so that way, in case anything happens, you're good there. We're also going to add a 20 amp fuse here for your rectifier. In case that thing starts overloading, it kills the power there. All right, and a 20 amp as well. Now we could eliminate one of these fuses by running this wire up to here and putting the fuse over here, and that just makes one fuse. But we might leave it like that for now. So off the key, when the key turns on, we're going to have another wire come up and over here, and that's going to be your block for your fuse block. So on your bike, you have 4 fuses. So you have 4 things you can run power off of. All right? So our power is going to be our headlight, our tail light, our coils, and power to those coils. All right. So that's it, and the horn. So that's all we're going to need. And because these are fused, we don't have to put an inline fuse anymore. So draw you a front brake switch there. All right, and then beside it, a rear brake switch. We're going to draw a line that feeds to the rear brake switch, the front brake switch, and go ahead and put your horn right there. And then you'll need a front headlight, and then beside that, you'll need a brake light. Okay, so let's understand this. All right, power's going to the key. We turn the key on, right? That feeds power into our fuses. So now we have power going out our headlight and our brake light. We don't want the brake light coming on all the time, but you have running lights that'll stay on. Okay. So you will need power going to that so that it stays on when you turn the key on. Then the bright light only comes on when you hit this or you hit this. And you want power on the horn as soon as you turn the key on. And you'll want power on the headlight as soon as you turn the key on for the low beam. But with yours, we want the low beam to come on and the low beam on the rear to come on. So we'll run a line straight off this. We'll go into here and then it'll tee off and go into here. You'll write low beam, so we know that's a low beam. And then it's fused here, right? So we don't have to run any fuses in there. All right. So if anything goes wrong with the wiring in here, it'll pop this fuse. Everything else will work. So if you're riding and all of a sudden your headlight goes out, then your bike will keep running. Everything else will keep operating. So you'll know, okay, it's just my headlight and my rear light don't work now. Check that fuse. Or it's the wiring from here up. Now, we do want a way, though, for this to get bright and for this to get bright when you hit the brakes. Now, let's also run us a line to the horn because we want the horn to be able to honk. Let's start with the headlight. You got a low beam already wired in, so that's done. You got a horn now. So how do we make the high beam come on and how do we make the horn work? Well, we have hand controls.
Okay.
Right? So there'll be a switch you'll hit for a high beam. Then for the horn, you have a button as well. Right?
I need a wire that goes to that unit.
Yeah. So the way you'll activate the horn is you'll push the button, right? Now you already got power going in. So when you push the button, it doesn't send power to it. But if you have a horn and you hook just a hot up to, is it going to honk?
No.
No. Why?
Because you've not activated it?
No, it's got power.
Oh, yeah, that's right. I'm not sure.
Okay. If you have a battery with a negative and a hot terminal,
yes,
and you take a wire and you touch that positive, right?
That's going to produce power.
It's going to produce power, right? But is it going to spark anything if you touch anything?
Yes.
No.
No?
Because the ground's not hooked up.
Okay.
Yeah. Right? So a lot of times when electrical things start getting wonky on a bike, like intermittent cutting out or weak spark or something, not a lot of people think to check their ground. Because if your ground's not good and connected, or you don't have a ground connected at all, there's no completing of the circuit. Right.
Okay.
So your horn button will work off of a ground. So when you hit that horn button, you're sending the ground from the battery to here.
Okay.
Right? And that connects the circuit. When you let off the button, it lets off the ground. So let's draw the left-hand control because that's where all your controls are going to be. So off the hand control, you're going to have a horn button. So you're going to run that wire right to your horn button. Now off the hand control, since this is hot, we want to just send ground to it, right?
Right.
So we're going to have a ground come off here, and we will actually tie this in somewhere to a ground wire, but because we're not just going to ground this to the handlebars or ground it to the frame. We're going to have where all these grounds come together,
okay,
and then they're on the frame.
I see, I see.
So that way all the components have a good ground because they have all these wires come into one ground and it's grounded good.
I understand.
Okay. So if you have a problem with electrical stuff and intermittent or getting weak, you check your battery ground, but then there's also one place where you check your ground for all the wires. Right?
Okay.
So that simplifies things a whole lot for us. So now when you push the button up here, your horn works. Okay. Now the high beam, same concept, but this is a little different. With the high beam, you've got the low coming in already. So the lights are going to come on as soon as you hit the key. Okay, on your headlight, you'll have 3 wires. You'll have a ground that runs to your main ground. You'll have a hot wire for your low beam that runs right here off your fuse. You'll have a hot wire for your high beam. That's only fed when you switch it to high up here.
Okay, I get that.
Okay. So your
separate.
Yeah, so your low will actually stay on, and then when you switch the high beam, the other element of the bulb kicks in. So your low and highs run together. Okay. So you'll need a wire running off here into your control. Now you won't put a little dot there because these are passing under each other and around each other, okay? Now you also run a wire off here for your ground. So the way we have it now, push the button, your horn works from the ground. You push a button now, and this high beam is fed, right? There you go. And so that works your highs and lows and your horn. That's all you have up there. But remember, this is a hot wire, so we need hot going in.
Into the control.
Into the controls, correct. So we'll need to use one of these to go into our...
Or would you come right off the battery, put a fuse in, and then go up?
No, because you have this fuse block, that's what they're for. Now we have our rear brake. The way we have it wired, the low beam comes on as soon as you turn the key on. So now we need a way to activate the bright light. Okay. So off this, you'll have another ground. Let's study on it. Okay, so we have the light that comes on. It's kind of like, just think of it just like the headlight. So we need something that activates the bright light on this, which is the controls. So kind of the same concept as the switch up here. It's the same thing that happens when you hit the brakes. Let's look at this for an example. Here's your tail light. There should be 3 wires coming off this. There's not, because one should be a ground.
Okay.
All right, they have the key on, boom, run straight. And notice on this key on, what's missing in this line?
A fuse.
A fuse, right.
Because it goes directly to the switch.
Right, see, so there's no fuse running here. If that wire that runs all the way from your key to the back of your bike was to get rubbed by your tank or something, that would melt your whole wiring harness. That would burn up the key ignition, that would burn up your light, and could melt the whole wiring harness.
That much damage?
Yes.
Wow.
So there's another no-no to do. Okay. So you have power in, they're feeding it right to the light, okay, just like we are. Okay, so we're good there. Yes. All right. They have the front brake switch. They have it running all the way to your bright in the back. Okay, but they have power from your fuse that goes to this too. Okay. So you will want a wire off of your fuse to run out here, to run over here and down here.
To the rear brake light?
Both.
Both.
To the switches. Yeah.
Okay.
Okay, so key on. Power goes in. Power comes out this fuse. Power up both switches. Okay. So when you pull that handbrake in, you'll want a wire going here, or joining these 2 wires together, okay? And then going in here.
Oh, I see.
And that activates the high, yeah. So no matter if you hit the front, or you hit the rear, or you hit them both at the same time, as long as you hit one, it's going to activate this bright light, okay? And it's already fused as well. So the only thing left now, we have a charging system, we have a key ignition, we have headlights done, we have a fuse block done, we have our hand controls done, we have our horn done, and we have our braking system and light done. So the only thing left now is how does the bike actually run. So we have all this real estate here. Now on Harleys, you'll find sometimes just 1 coil. They don't have 2.
Good.
Yep. Okay. Even though they got 2 cylinders. Okay. So some coils are set up on Harleys to it sparks at the same time. So both spark plugs fire at exactly the same time. Okay. One is on a compression stroke and fires. The other one is just wasted on an exhaust stroke, but they both fire at the same time. This is set up for 2 coils. So only 1 wire will fire for this one and only 1 will fire for this one. Now this is important because if you get these backwards, your bike won't run. Okay. It'll be firing at the wrong time. So we've got to be very careful with the wiring on this and making sure we wire this correctly. Now, I don't know the colors that's on the bike yet till we get over there and get into it. But what I do know is we can go ahead and lay out the wires coming out. So what we'll need are 3 things. We'll need a motor, or let's call it timing ignition. We need our coils, and we need the actual ignition unit. So those 3 things we'll need: the ignition timing, coils, need 2 of those, and the ignition unit. And you can spread them out. You got all this to work with just those 3 things. So you got 3 wires that'll come off of that unit. They will all go into here, all 3 wires. So no matter if you run them over here, run them over here, whatever your preference. Okay, that feeds the signals into that CDI box. Now, again, we don't know the color of them. We'll find that out when we go over there. Now, from the CDI box and from the coils, we need power. We need to energize that up so the brains will work in here, the little circuit board and computer board. We need to power these up so they're ready and setting and waiting for that charge, right? So, where are we going to get our power from? But remember, this is a 4 fuse block. So on a 4 fuse block, you have actually 4 fuses and the wire coming in to feed the fuses. So we've used how many of those fuses?
4.
No.
No?
No. Because there's a terminal coming in that feeds power to the 4 fuse block.
Of course, 3.
So we've only used 3.
Right.
So we have 1 more we can run off here.
Right. I was thinking that was the 4th.
Yeah.
You're right.
So we're going to run a line here. We're going to go into here and we're going to go into there. Okay, guys. Sorry about that. My camera battery, the GoPro 11 battery, the original battery come with it, it keeps overheating. And it's not really that blazing hot out here yet. We're out here in the morning time. So I don't know what we lost footage-wise. Hopefully nothing, but here's our situation we got at the moment. We have the motor with the ignition timing coming out to the CDI box, the ignition unit box. And then we have one more block of fuse here. We're going to run out here to the CDI box. And then we're also going to feed power to the coils from that. So if we missed anything on the video, my apologies. I got to figure something out. I'm not having a good relationship with this
Should I
GoPro.
do 1 wire
what I would do, you could just run into that, or you could have just come out straight and dropped down, but what you've got's fine. So now, we turn the key on. We don't have to worry about any of this. We've already got it wired. Right. Except for this 1 wire we got to fix. So key on, feeds the fuse. Boom, sends power to the CDI box, to the coil on the left, coil on the right. The CDI box gets its signal from the ignition unit on the cam. So from that, now, we got to tell these coils when to fire. All right? Right. So you'll have 1 wire go straight to this coil, and 1 wire goes to the other coil. They're separate wires. Now, we don't know the color of these yet. We want to verify them on the bike. So at this time, Monty, you have rewired your entire bike.
That's it.
That's it.
Yes, sir.
Now, we've got to do something with this here. Okay. We've got the power that goes to the stator to energize this stator.
Yes.
And it comes out here and ties into here. And we've got this run up here. So we got to find where that goes. So this is what they've got, a brown wire here, runs in here, ties in here, goes into our block. Okay. So let's run this wire to tie in right here to this wire. And put you a dot right there so we know that connects there and doesn't connect here or here. So now when you turn your key on, boom, that energizes. This throttles the voltage down and charges your stator. Now your stator, before you even crank or kick, is ready and energized.
Okay.
Ready to go. Let's walk through everything so we got an understanding of how all this works since we made it. So you get on the bike, you're ready to ride. You hit the key. Your key has power straight from the battery. You got your inline fuse there. When this key is activated, it goes here. Charges your rectifier, sends voltage out to your stator. Your charging system is set and ready to go. Power goes into the fuse block. Key on, your horn is loaded, your rear brake low beam is loaded, your front low beam is loaded. These turn on automatically. All right. Your brake light switch is loaded and ready to go. And your, your hand controls are loaded and ready to go. On your hand controls now, before we even kick start, You can switch the high beam on and off. You can turn the horn, push the horn on and off. Now on buttons, you have what's called a monetary or momentary button. That's a button you push and it stays pushed until you let go and it pushes back out.
Oh.
Then you have a button that's an actual like switch where you'll switch on and switch off.
Okay.
So your high beams is a switch. You switch it up to high, you switch it down to low. Your horn button is a momentary button where you push it in for the moment and you let it go and it turns off. Right. So that's your hand controls. So now everything over here is operating. You come over here, when you turn the key on, power goes into here, power comes up. Your coils all of a sudden are loaded. Your CDI box comes alive. Now, when you kick, this sends signals out to here, and this sends signal out to this coil, this sends signal out to this coil.
In my mind, it's a load up with power, and then you have your signals after that in order to either regulate or use the negative or
That's a very good way to put it. Yeah, you're absolutely right. When you turn the key on, it loads everything, and nothing happens until you control it.
Right.
So a high beam or a horn or kicking to rotate the ignition timing. Very good way to think of it. Now, once the bike is running, then the stator is turning, sends a lot of voltage, AC voltage out here, and then this rectifier takes all that power, converts it into DC power, so it can charge a battery, that's DC, and throttles it down, so it's not sending a bunch back. It sends back, as you rev the motorcycle, this will send out more power to keep up with your battery draining down. As you let off the throttle, it'll throttle it back down. So it keeps a constant flow of good and bad charge on it. And that comes out through this amp, 20 amp fuse, and back to charging your battery. So notice on your battery, we have a ground. We only have 2 wires coming off here. Now, for the grounds that we have wired into everywhere here, we will probably have to run a wire through here, connect it here. Run it through here, connect this here. Run it through here. Your CDI will have a ground, I believe, doesn't it? It should. Let's look. Okay, your CDI is grounded from the ignition unit. So we don't have to, oh, nope, there it is, right there. Okay, so let's draw a ground on the CDI. So the only thing that we would change is I would run this wire along here. Okay, I would drop that in here to hit it. I would run this up through here. I'd drop that in there to hit it. I'd run this over here and drop that in there to hit it.
And we're doing that because we only want really one good solid line connection. If we had this will work, but then you've got so many more spots if things should go disarray.
Yeah. Wherever this negative right here is grounded out, we'll run all these grounds to that.
Okay.
Yeah. So that way, if you're troubleshooting, you know, okay, I'm going to check my terminal. That's good and tight. Now let's check this. And this is the ground for everything on the bike. So you have a ground here, you have a ground here. And as the wiring harness comes along the bike, we just tie into that ground, Okay. The worst thing you want is 15 different grounds on your frame of the bike, and you're like, where did I put this? And you're chasing grounds. Okay. So as we run a ground from your headlight, let's just tie in as we go. So you'll just have this butt in, then you'll still have a single line. You have this butt in, then you'll still have a single line. So you're not taking 15 wires and rolling them all together. You're just tying into that as you go. Okay? You don't have to worry about any fuses, it's a ground. You don't have to worry about it scraping the frame, it's a ground. You know, scraping the frame would be a good thing. Gives it more ground. Okay. So you're coming on, grounding, coming on, grounding. Coils now, there's no ground wire coming off your coils. So how are they grounded? They should be grounded, very good. But there's no wire. So how would something be grounded if there's no wire? So what do you ground this battery to? So the frame is a good ground, right? That's what you ground your battery to. Sure. So what are these grounded to? The frame. Yeah.
Separately on their own?
On their own.
Okay.
Yeah. So these are already grounded. You don't even have to ground these. So all you have to ground now, and this is grounded, this unit is grounded into the motor.
Right.
So all you have to ground to here is just run your line right there. So sometimes on bikes, if you're not getting good spark and you check here and you say, well, I'm getting power to the coil, it could be that it's not getting good ground. Where the coil packs bolt into the frame, sometimes those bolts won't get loose usually, but it'll get corroded underneath. Like a negative battery terminal sometimes gets corrosion on it, and you'll just take the coils off, clean them, put them back on your arm. That was the problem. So they're grounded actually to the frame. Well, Monty, you have built your own wiring harness for your bike.
That's cool.
So all we have, and we have the instructions now. So now all we have to do is go over to the bike and we'll unplug everything, take all the wires off. And then we'll say, okay, I want my ground wire. Let's see, it's black. I want it to be black, or I want it to be green.
Okay.
And then you'll write in whatever color we put on, whatever you pick. We'll put it all on, and then we'll start testing everything. So before we crank the bike, we'll turn the key on, okay? What's supposed to happen when we turn the key on? Well, let's test it and see if it does. Does the headlight come on? Does the tail light come on? All right, so now we're ready to move to the bike. Congrats, my man. Okay, so we got our instructions, we got our template. Monty did a wonderful job of putting everything together, laying it out how he wanted to. So let's start taking all of this unnecessary stuff off. What I'd like to do, unplug every unit that we wrote down on paper, get all the wiring off this bike. Now I want to show you something they did that is a no-no. Okay, come in here, Monty. Monty's my cameraman today. Might have to hire him professionally. Don't use these little tie-in wire things. Do you see that? That is so bad. So bad. Also, these, the way these are designed, they have a needle here that pierces the wire you run these through. So the only connection you're getting to this wire is that little bitty needle. If you're running a lot of power through something, you want more connection than that. These also, just see how that just came out. So this no doubtedly came with the kit, the aftermarket wiring harness that you would buy, kind of a DIY build your own, but do not build your own with these. So what I want to do is take all these off and throw them in the trash. And look at what it does to the wire there. Look how it just mangles and destroys that wire. So we're not going to use any of this. So I'm just going to start taking the time to take all of this apart. Now that we have our diagram, we can strip everything off the bike. We don't have to worry about even colors, because as we put things back together, Monty's going to pick his colors. And then we'll just add that to the diagram that he drew out. And he's going to get to take that diagram home with him and hang it on his wall and be very proud of it. And then as he's riding, if anything goes wonky on his bike, he can grab that diagram and say, there, that's exactly what it is. Let me go check that. Now, once I get all the wiring off here, everything unplugged, we're going to walk around and look at all the components. We're going to write down what wires are left from stock, so we know the colors and what they're going to go to when we feed wires into them. Now, I did see on here, there's a relay. Now, this is a relay for the LED, but there are no LED lights on this bike. Maybe the tail light's LED. Now, let's talk about LED. When you run into replacing things from bulb to LED, LED is brighter. You can get them brighter. LED lasts longer. LED requires less power. But there's an issue with that. If you have turn signals and you have a flasher relay, a mechanical flasher relay that looks quite a bit like this, then that relay takes a certain amount of power or pull from the bulb to activate that mechanical relay to get it to click on and off and on and off. LEDs don't draw that much power. So you'll find if you swap your turn signal lights out, for example, with an LED bulbs, it's not pulling enough of that power to activate the switch. So you either have to get an LED relay that's designed for LEDs, or you can put an inline sort of adapter for that. It's like a little heat sink kind of looking thing that will then pull that power in and throttle it down for the LEDs. There's no LEDs besides the brake light, but I think it's going to work fine, so we're just going to delete that. So here's the fuse block that we drew in to our diagram. If you want to move in here in Monty, you can get a good look at that. So here's what I was talking about. Here's the power coming in from the key switch, okay? Here's your 4 fuses that go in, and then these are the feeding out of the 4 fuses. So we will be reusing this. We'll just disconnect it. And if you look up here on the top of this frame, okay, they've even made a provision for this to set down into, so it's kind of nice. Made out of little foam. They got a provision for the CDI box here, and even a little provision for the battery, for the little battery, and a custom seat to cover it all. So pretty cool. Let me get looks like maybe a 10 millimeter on this to take this off to get all this out of the way. Now the good thing is on this, we already have an inline fuse that's made into this. But now here's the problem with these. If you delete these and go to get rid of this, okay, and take this off, guess what has happened to your wire? You have a hole in your wire now. See that? And so if this touches anything metal, so we're going to have to put a heat shrink over this and shrink this to protect this. So don't use these. I hate these. I hate these. But we can use that inline fuse now for the one inline fuse we have running from the battery over to the key on and out to the rectifier. So we can put whatever size fuse we want. If we want to put a 30 in there, we could go up to 30 since so much is running to it. So the CDI box, we'll go ahead and unplug. So here we have the stock CDI wires here. So we can look at our diagram and know exactly what those wires run to. They're still color-coded stock. And then from here, we already have good connections. So we can reuse these and then just run these wires where we need to. Our brake light switch or our brake light is the same. Now you'll see a bunch of wires in here. We only need 3 of them. Maybe even just 2 because it might be grounded to the frame here. We'll have to check and test that. But this has provisions for turn signals. So we're not using that. Now we won't cut these out. We'll just leave it. And then when we go to plug, oh wow, we just lost power. We just lost power in the shop. So when we go to plug this back in, we can delete the turn signal wires, leave enough that if you wanted to add turn signals, you could, and then we'd have to add a turn signal unit back here. All right, so that's done. That's done. This is all done now. See how the wires are coming off, Monty? So here is your rear brake switch. So it's not actually attached to your brake up here on the back, but there's a spring so that when you push that switch down, it pulls this little lever down and makes the connection for that. So these are still stock. We'll pull both of those off. So we're getting places. Okay, that's a plug wire. Getting rid of all this stuff here. We got rid of that. So see how that coil? It's like that. That's not going to be a good ground for us. So we're going to take these off when we're ready to fire the bike up. We're going to clean off there and make sure they're getting a good contact. Sometimes if people have frames powder coated, they won't think to shave it down to bare metal so this gets a good attachment. So we'll need to definitely fix that. But we'll pull this off. Okay. On your coil, you have an orange and you have a red and white. On the other coil, you have an orange and you have a red and white as well. So we'll need to know which is the power that feeds both of these and then which is the individual signals. We'll have to look that up in our OEM's factory wiring diagram. As the cam turns, this sends signal to that brain box here that says when to spark each coil and how fast to spark them. We can go ahead and take that out. So we can just disconnect this. The only thing that's going to be running into this from now on is 3 wires. That's it. So all of this is going to be deleted. Every bit of it. So I'll just take the time to unplug everything just so we can feed it back out. Yeah, hopefully our power will come back on soon. It must be working on something. Hopefully nobody hit a light pole and hurt themselves. Now I know the first time you jump into this, it's kind of scary. Like, how are we ever going to get all this back together? But now that you've sat down and written out the diagram, you can see kind of how simple it is and how easy it is. If you can just follow the diagram, you'll be fine. Then if we, we hook something up or forget to hook something up, it's easy to just go look at the diagram and say, well, let's check this wire and let's test this. And goodness gracious, how did they even get the headlight on this thing with all this mess? So Monty, that's what we're deleting. So you can already tell how clean and nice the bike's going to look without 20 pounds of wire. Now we'll be using these connectors, of course, again, but everything is going to be tight. It's going to be tucked up in here. It's going to come under here and be harnessed and zip tied, and you won't see a bit of wire except for, of course, where it comes out the headlight into here and runs back up here. So this is going to eliminate a whole lot of stuff. So now we can just pick a system, a unit to start with, and we'll start running wires to that and plugging up. We'll go ahead and put the headlight back in because we're going to start just rewiring all of this bike. Okay, so Mr. Monty and I have been hard at work. We have got the majority of the wiring done, and we've used his previous wires. That's what's left of it. So quite a bit we cut out. We trimmed all this up nice. We'll of course harness this, zip tie it to this rail here. The tank will cover over that. You'll never see it. We're going to clean all this up in here. We're using his fuse box. So we tried really to use everything that he had. All this will get cleaned up and connected. But we're at a point now where we can test some things out. So with the key on now, we have headlight, we have tail light. I'm going to go, if you want, and pull the handbrake. We have brake light on the top and then on the lever at the bottom as well. Brake light there, so very good. He's going to run no turn signals, just do the hand signals. And I'll tell you, when we were wiring in the ignition back to the ignition unit, the CDI box, the brain box, boy, did we have trouble. And I ain't kidding you. We spent probably a good 2.5, I'll probably say almost 3 hours. These wires off this is just 3 wires, but they're different colors on the diagram. The CDI box matched up, but we didn't know which 3 wires of those went into this and how they went in. Oh, we tried every combination of wires, I felt like we were breaking into some bank safe, trying all the numbers. Nothing worked. I remembered Marty when we turned the key on the bike, he said, oh, look, we got a light on. Well, what we discovered is these lights come on when a fuse blows. So we had been chasing rabbits with no spark for 3 hours, and it was a blown fuse. So once we replaced the fuse, it only took us a couple of tries to get the wires right on this. And now we've got our fuel line hooked up. We're going to choke this bike. We're going to let the lift down, and Monty's going to give it a kick for us. Now the right side exhaust is off, so if it sounds poppy like a balloon, that's why. All right, Monty. Good job, good job. So we still got a lot of work to do on the bike. Monty's got to head back toward Canada tonight. And so wish him safe travels. Hopefully by the time you see this video, he'll be back home with his feet up. But we still have some things to do. The reason we're stopping here is he decided he wanted to get rid of that big bulky turn signal switch, passing light switch, the big housing that's on the left side. He wanted to delete it. And we're going to go with a simple, nice, black 2-button. So the top button will be his high beam, stay on and stay off. And then the bottom button will be a momentary horn button. And so we're going to order all that stuff. We're going to do probably some enduro / tire scramble like tires. We're still kind of thinking on that, chewing on that. We're going to go through the valves on this. We're going to go through the carburetors on this. We have an oil leak that we got to address. Unfortunately, he already brought up some gaskets to go through that. We're going to check brakes out. We're going to do fork seals on the front because the forks seemed a little bit too loosey-goosey. And besides that, we still have to wire in the rectifier and the stator to charge back the battery. All the other wiring is done except for our horn and our high beam light switch. But we have running lights. We have the bike actually running now. It means the CDI box is doing well. The electronic point is doing well. Carburetors seem to be sounding good, but we'll check them out and go through them. Our brake light switches are working. So we got a lot done today. We've been out here sweating. I mean sweating. Mine's from Canada now. He's not used to this type of stuff. He's going to go home and freeze his tail off. I'll tell you that right now. So this is part 1. Stick around very soon for a part 2 once we get some of these in. And then we'll get back on this iron head build. And I'll tell you, one of the reasons I like doing what I do, you never know what's coming in the door. And I had 5 bikes show up last week. So I'll give you a video of walk around on them. So our shop is loaded to the gill. We're going to have a lot more fun in the shop, me and you, and Monty watching from Canada. So do me a favor and tell your mama and them I said hi.